You may start when you're ready. When we get to close to 8 minutes, I will just raise my hand and just say 1 minute left. Okay? So you tell me when you're ready.
We present our project is cooling systems. Today, when data centers is switching to new generation of processors, are faced in the fact that existing server cooling system cannot cope with the amount of heat realized. Existing server cooling systems based on forced convection are limited in heat dissipation, are leading to overheating, downtime, and reduced server density. Up to 40% of data center energy is spent on the cooling. And while overheating causes downtime and multi-minute losses, there is a tendency to reduce this distance between server racks, which makes it necessary to switch from traditional cooling system to a new cooling system. It allows the consumer install more and more server racks in machine room and increase customers' profit.
So the key idea of our solution is to use phase change for higher heat through capacity, because during boiling, much more heat needed. So current solutions based on single phase change are physically limited and cannot keep up with modern CPUs and GPUs. So to validate our approach, we will compare our two-phase mini-channel cooling system with a usual liquid cooling system, showing significantly higher heat removal capacity.
We propose an implementing of evaporating cooling system with mini-channel surface and employ forced pumping. And we propose that it would allow us to double server density in each rack and also enhance chip durability.
Also, let's talk about the marketing opportunity. As you see in the chart, the marketing opportunity of these cooling systems in the companies is increasing rapidly and really enormous. In 2004, it was $22.1 billion, and as you see, it is estimating to 2023, it's going to be 56.1%. It seems that's 70% per year. And also the overheating for the companies is a really big cost. The companies estimates that the overheating of the classic systems are $7,000 to $9,000 per minute. So this is a huge amount. But our project, it's going to reduce and prevent this cost in a long term. So the next steps, as you see, that what we did in our presentation, in our project, in the first weeks we were have some information with interview with the electorate data center in Moscow. We collected some data, and after that we created some heat sinks 3D models, and our next step is going to create prototypes in mini channels heat sinks. That it's a method, it's going to be two methods. It's going to be 3D printing for laser vials, and after that we are going to test them in run validations and the final batches. Thank you for your attention.
Thank you very much. It took 5 minutes. 5 minutes rather well spent. Before I give
the floor to the mentors. Just as a professor, on slides, please put slide numbers, because if I want to refer to a particular slide, when I take notes, it's good to have the slide numbers. That's one thing. You put some figures, but it's not clear what sources you have selected. So it's good sometimes to have either sources written at the bottom of the slide, or if there's not enough room, just put that in some backup slide. Okay, it's very important to cite your sources, because you say, okay, 200 million robots, who is going to use that? I mean, is it an aggregated amount? It's million robots or billion robots? Dollars, okay. So $200 million in Russia. $200 million on the scale of the planet, it's not so much, but still. Okay? And you spoke about the market at some point, because you gave some figures in robots, no? Or only in dollars? Because here it was 200 million robots, yes?
Yeah, robots for a data center in Moscow.
So this is for one data center in Moscow.
Yeah.
Okay, so I missed that piece of information, and probably you talked about it. And the market, because at some point you speak about market opportunity, it's not clear. This is worldwide or Russia? Worldwide. And these figures are based on which source? Right, okay. So, thank you.
This is, I mean, with the growth of AI centers that are using incredible amounts of computers, isn't anyone already done this? Where is your competition?
We will add the slide about our team more later.
Yeah, I think it's an important point in order to really check, is this money available to you as a client, or is somebody already way farther ahead? I can't imagine that it's not actually being worked on now.
Thank you. For me, we can't describe our customer as the problem, because when you're talking about data centers, and that I understand this is the subject of your project. But you need to understand that somebody operates those data centers, and here is the customers. And I think it could be a great step for you to improve the project, to understand which kinds of clients we will have. Because some of data centers are owned by private business, some of them owned by big corporation, and some of them operated by government. And here is 3 different types of customers. Understanding of each of part of them allow you to create your market and to calculate your market share. So unfortunately I can't see this from the presentation, and I can move here in this direction.
This number, 200,000 million rubles, was it a confirmed number from potential customer, or how did you acquire this number? From a data center accelerate in our in our conversation from phone.
Okay. Since we talk also about Russia, in Russia we have pretty cold winters. And wouldn't it be in Russia more rational to put all this heat into like heating up something else near your data center? And how your system could be, you should think about how your system could be implemented and competitive in different areas of the world with different environments.
Yeah, I think I understand your question, but the main problem is actually the heat flux density in the microchip.
Mm-hmm.
So it's not a problem to remove all this heat to somewhere, but the problem is to remove so much heat from so small area.
Okay, and also have you somehow tried to count the difference in prices, self-cost of your technology and the already existing solutions? Have you tried to compare this?
Not yet, but one thing I can say that, for example, liquid flow rates will be less, so we need to cool less liquid, and this is less electricity, and this is cheaper. But for production of this system, we didn't calculate yet.
Okay, thank you.
Thank you. Yes, if you have comments later.
Yes, thank you. So, for one, on the forum, on each presentation, you have always to have three things. Skoltech brand, always. You are here in Skoltech, you are part of Skoltech community, you have to have it branded. You have to have your team number and probably team logo if you have one. Because yes, you have this Skoltech brand on the front, but it should be on every slide. And also you have to have slide number, as Professor said. So about the actual scientific validation slide, I would like to add that this kind of presentation is not purely your scientific course. The validation should be understandable for everyone. Consider this as an investor presentation. Investors do not have to understand what this means, how it works. It has to be understandable from the slide. And also about your Gantt chart, remember that we have only 2 weeks left. And you have in a Gantt chart to distribute the tasks by the actual team members. Because otherwise you have a mess during the team work. Thank you.
Thank you.
And yes, a brief recap of who you are, to demonstrate that you have the expertise, of course, for this. And who's going to do the modeling, who is going to do the prototyping. Do you have the competencies, or do you plan to just, let's say, have someone do it for you?
No, we have our own competencies.
Okay, but at the next presentation, I would like to know more, of course, about you. And okay, thank you. That will be all for now. Thank you.
Thank you.
Yes, piece of advice also.